Hi everyone, today we are going to continue the 10-1 notes and we're going to focus on factoring. Now remember when you're factoring you always want to look for the greatest common factor first, other known as the GCF, okay? Up here is just like a little chart to just review for factoring. If you have 2 terms, 3 terms, and 4 terms. If you have 2 terms you want to look for the difference of squares, so something like this, sum of cubes and difference of cubes. If you have 3 terms, you want to look for perfect square trinomials or guess and check. And then 4 terms, you're most likely going to just go ahead and group. All right, before we get started, a couple of things I want to go over, just some vocab. If x equals a, so just a number, is a 0 of a function, then all of these statements down here are true as well. That means that x equal a is also a solution, and it's also a root of the polynomial function. So you might hear me say that a number is a 0, a solution, or a root of a polynomial equation. Also, that means that x minus a is a factor of the polynomial. So before you said equal to 0. And then that means that a 0 is an x-intercept of the graph. Okay, so down here, we have 12 questions to do. We're going to factor the equations below and find their solutions, okay? So over here, this is a 3-term polynomial. So I know this is not a perfect square trinomial, though, because I can't take the square root of the first or the last term. So I'm just going to go ahead and do the guess and check method. So I know that x times x is going to give me x squared. Factors of 20 that add or subtract to give me -1 are 4 and 5. And let's see, I know one of them has to be negative and the other one has to be positive, because when I multiply 2 numbers together I need it to be negative. So I'm going to say -5, +4. So x times x is x squared. 4 times -5 is -20. Also, 4 minus 5 is -1. Remember, these 2 terms added together should equal that middle term there. So then when I set each of these factors equal to 0, I get x equals -4 and x equals 5. All right, number 2. Over here, first, it looks like I might have a GCF. However, I cannot divide 9 by 2. That won't be very pretty. So this is 3 terms. It's not a perfect square trinomial. I can't take the square root of those. So let's go ahead and guess and check. And I'm setting these equal to 0 because we're finding their solutions. So I know that I'm going to have x and x, and also one of these is going to be a 2x. All right. Now, factors of 18. Let's see, we got 6 and 3. We've got, let me write it like this, 6 and 3. We've got 9 and 2. You've got 18 and 1. So let's check it out here. Remember, these 2 terms together have to add to that middle term. So if I plug in a 6 right here, these 2 numbers give me 12, and these 2, I need a 3. 6 and 3 give me 18. That gives me 12x. This gives me 3x. I can add 3x and 12x to get 9x. So I need one of the terms to be negative, though. So I will need this to be -12, +3, so they add to -9. So that means I need this to be -6 and a +3. Okay, so 2x squared, that'd be -12x plus 3x, which is -9. 3 times 6, -6 is -18. Set those both equal to 0. So 2x plus 3 equals 0. So 2x equals -3. X equals -3 over 2. And then over here I'm going to have x equals 6. Okay? Circle these, whoops. Alrighty, down below. Let's keep it going. Alrighty, over here, no GCF. There's only 2 terms. I can take the square root of both of those terms, so this is a difference of 2 squares. So remember, you're just going to take the square root of the first term, which is Square root of 25 is 5. And then plus or minus, and the square root of the second term is x. Set those equal to 0. So this is going to give me x equals -5 and x equals +5. Okay. Number 4. Let's see here. No GCF. This is not a difference of squares because I can't take the square root of 5. This one's actually not factorable. So we can still set it equal to 0 though. And we can solve for x. So that would give me x squared equals 5 when I add 5 to both sides. Then I would take the square root of both sides. So x would equal plus or minus the square root of 5. Okay? Again, that one's not factorable though, so you can't factor that. All right, number 5. Okay, nothing special here. So let's see. X and x gives me x squared. Oh wait, actually, this is a perfect square trinomial because I can take the square root of the first and last term. What's the square root of the last term? It would be 5. Square root of 25 is 5. And because when we multiply these two together, we need it to be positive 25, so these either have to both be positive or both negative. Well, think about it. This middle term is positive 10, so when I add these two terms together, these numbers multiply together, and these numbers multiply by each other, when I add these two, I need it to equal 10x, so I need those both to be positive. So my solution here is x equals -5. Okay? Even though the factor is written twice, we just have to write it one time. All right, over here, let's see. We have no GCF. We do have we can take the cube root of the first and the last term, and there's a minus sign right there. So this is actually a difference of cubes problem. So to set up the difference of cubes, you do a minus b. Your a term here is the cube root of the first term, which is x, and then the b is the cube root of the second term. So the cube root of 27 is 3. So right here, difference of cubes, if you look up top, it's a minus b, so x minus 3. And then I have a squared, so x squared, plus a times b, which is 3x, plus 3 squared, which is 9. Okay? Now notice that you can't factor this out anymore. Okay? There's no factors of 9 that add or subtract to get you 3. So that's it. And you have x equals 3 right here. And then we would actually have to graph this on the graphing calculator to solve for those other x values, which, and you can find those would be the zeros on the graphing calculator, which I don't have my graphing calculator near me. So we'll have to come back to that one. All right. Down here, we have a sum of cubes. So my a value, cube root of x to the third is x, and my b value, the cube root of 125 is 5. Sum of cubes says do a plus b, and then do a squared minus a times b plus b squared. Okay, so we have x equals -5, and again, type that in on the calculator, graph it, and then find the zeros. Okay, number 8. All right, we have a GCF here. We can factor out an x out of all of these. So we have x squared plus 2x minus 8 equals 0. Oh, I should have set these equal to 0 as well. My bad. Okay. Let's see here. So this is x. Now you need to see if you can factor this down further. This is just going to be a guess and check. Oh, whoops. I don't know why I wrote x squared. Factors of 8 that I subtract or give me 2 are 4 and 2. let's see, I need this to be a positive 4, and this a minus 2. 4 minus 2 is positive 2. Negative 2 times 4 is negative 8. So my x values are x equals 0. Do not forget to set the GCF equal to 0. A lot of people forget that. Set that GCF equal to 0. So x equals 0, x equals 2, and x equals negative 4. Okay. All right, a couple more. 9, 10, 11, and 12. Okay, number 9. Okay, here, no GCF, right? But there's 4 terms, so we factor by grouping here, okay? Now you find the GCF of that first pair. So looks like it's going to be x squared. So I'm left with 3x minus 2. And then remember, when you factor by grouping, you want this to be the same as whatever you get over here that's left in parentheses, okay? So I want this to be 3x minus 2. It looks like I'm just going to take out a 4, positive 4, and that gives me 3x. 4 times 3x is 12x. Negative 2, 4 times negative 2 is negative 8. Perfect. Those match, so I'm good to go. I'm doing it right so far. So I have x squared plus 4. You just bring these two guys together and make them one factor. And then I have 3x minus 2. So they're the same. Equals 0. And then let's go ahead and solve that. So x squared plus 4 equals 0. And 3x minus 2 equals 0. So x squared equals negative 4. X equals plus or minus. Now, you guys learned last year, when you take the square root of a negative number, you get imaginary numbers, okay? So, the square root of 4 is 2, and the square root of negative 1 is I, all right? Over here, we're going to get 3x equals 2, so x equals 2 over 3, okay? Alrighty, number 10. GCF would be x squared. That's the most amount of x's we can take out of there. So I'm left with x squared minus x minus 20. Oh wow, this actually is very similar to number 1. So this is x squared times x plus 4 times x minus 5. Okay, that gives x times x is x squared. 4 times negative 5 is negative 20. 4 minus 5 is negative 1. Set these all equal to 0. Remember, don't forget to set the x squared equal to 0, okay? So x equals 0, x equals negative 4, and x equals 5. All right, number 11. Let's see, we've got, we can take out 4 out of all of this. So we have x to the 4th plus 3x squared plus 2. Okay, let's see here. This one's trying to be tricky. Alrighty, so I can do x squared times x squared. That would give me x to the 4th. The only factors of 2 are 2 and 1. And to make that a positive 2, 1 times 2 is positive 2, and 1 plus 2 is 3. So there we go. Okay, equals 0. Again, we have to set each one of these equal to 0. So real quick, does 4 equal 0? No, so you can leave that guy alone. So we're really just going to set the factors, these two, equal to 0, okay? So x squared plus 1 equals 0, and x squared plus 2 equals 0. So x squared equals negative 1. So x equals, the square root of negative 1 is just I. Okay. Now, the reason why we don't do plus or minus on that is just because the square root of negative 1 is I. The reason why we did plus or minus here is because of the 4 that was under there, okay? And then I have x squared equals negative 2. So x equals plus or minus I squared root of 2. Okay, we take out an I because there's a negative 1 under there, and then we're just left with the square root of 2. I like to write the I in front of the radical so then we do not have to worry about if it looks like it's underneath the square root or not. Okay, and the last guy, number 12. Okay. No GCF. It looks like we might be able to take out an x, but we can't. There's 4 terms, so we're going to factor by grouping. So let's see here. The GCF of the first term, or the first group, is x squared, so I'm left with x minus 3. So remember, that's your goal to get in the second part over here. So it looks like 9 and 27, I can divide those both by 9, but what you want to look at is, do I want to divide that by positive 9 or negative 9? I'm going to take out negative 9 because now that makes this x positive, and then 27 divided by 9 is negative 3. Now these guys match. If I would have taken out a positive 9, this would have been negative x plus 3, and we can't have that. These have to be the same. Okay, so now put these two GCFs together. So x squared minus 9 and x minus 3 equals 0. And then we actually can factor this further, right? This is a difference of 2 squares. So, sorry, it's a little messy. X minus 3. So x plus 3, right? That's the difference of 2 squares. Look above if you forgot. And then I also still have an x minus 3 right here equals 0. So I get x equals 3 from this guy, x equals negative 3, and I get x equals 3 again, but I don't have to write that twice. That's why you guys did that multiplicity video first. All right, hopefully that got your gears going. Again with factoring. Hope that helped.